I welcome class 7 students to this chemistry chapter. This is class 7, subject is chemistry, and the title of chapter is language of chemistry. In this chapter we will study about chemical reactions and how a chemical reaction can take place and how we can understand that the chemical reaction produces some products also. We will also check some examples of word equations, and after going through this chapter, students will be able to name the reactant and product. They will also be able to write a chemical reaction in form of word equation, and they will also recognize the usefulness of a word equation. So let us start the chapter, and we are first discussing the definitions of a few basic terms. Now let us see definition of chemical reaction. Any chemical change in matter which involves its transformation into one or more new substance is called chemical reaction. It also involves transfers of energy, atoms, and many more things. So students, let us see one of the example. The substance that undergo changes are called reactant, and the new substance formed are called product. So this is the basic chemical equation. Both reactant and product are pure substance like elements and compounds. So let us see one example of a chemical change or chemical reaction. Now this is example number 1. Hydrogen react with oxygen to form water. It means hydrogen and oxygen are reactant and water is the product. Now what happened to the hydrogen and oxygen? The oxygen and hydrogen atoms changes and forms water molecule. The atom of oxygen and hydrogen in their molecule rearrange themselves to form water molecule. One molecule of water contains 2 atoms of hydrogen and 1 atom of oxygen. Now it has been observed that the total mass of a reactant and product is equal to each other after the reaction. It means their chemical mass remains unchanged because they have to satisfy law of conservation of mass or law of conservation of matter. Now this is the basic word-line equation of law of conservation of matter. Matter can neither be created nor be destroyed. It can only be transformed from one form to another form. Take second example, sodium oxide reacting with water to form sodium hydroxide. This is also a word equation in which sodium oxide and water changes and new substance sodium hydroxide is formed. Take us third example. This is a potassium chlorate, and it on heating changes to potassium chloride and oxygen. In this reaction, potassium chlorate is a compound which decomposes as we heat it and changes to oxygen gas and potassium chloride. So in all of the cases, chemical reaction can involve a combination of 2 or more elements, or it may also happen that one substance decompose or break down to form 2 or 3 substances. So whenever there is a chemical change or a chemical reaction, we can say both are occurring together. It means chemical change and chemical equation are same thing. Let us see activity number 1. This activity is very simple. Take a small amount of sodium carbonate, a white solid in dry test tube, and add 2-3 ml of dilute hydrochloric acid. Now what happens? You will see brisk effervescence. Effervescence are bubbles indicating the evolution of a gas which is a new substance, carbon dioxide. At the same time, some heat energy is also given out. It indicates that a chemical reaction has taken place between sodium carbonate and hydrochloric acid to produce new substance. You can see effervescence are seen here. This is the word equation, sodium carbonate plus hydrochloric acid. It gives sodium chloride, water and carbon dioxide. Now students, let us see how to create a reaction or how the reaction can be started or continued. A chemical reaction takes place when one or more of the following conditions are fulfilled. So, first of the condition which is required to be fulfilled is close contact. For a chemical reaction to take place, the reactant must come in contact. So, it means that they should be mixed. For example, sodium reacts with water violently when they come in contact with each other. Now you can see this is sodium, this is water, and after the reaction sodium hydroxide and hydrogen gas is produced. Now consider a situation if you are not bringing sodium in contact with water, the reaction will not take place. Now this is also a matter of precaution. Sodium is kept in kerosene oil so as to prevent its contact with moisture. Now second condition required for a chemical reaction is solution form. Now students, please pay attention that these all conditions are not necessary in every reaction. Sometimes we need one condition, sometimes we need other condition. So second condition is a solution form. Some substance react with each other only when they are in solution form or they are mixed in solution form. For example, sodium chloride solution is added to silver nitrate solution. A white precipitate of silver chloride is formed and sodium nitrate is formed. Students, look at this reaction. This is silver nitrate, this is sodium chloride, and after this is silver chloride, white precipitate is formed. If sodium chloride and sodium silver nitrate are mixed together, no reaction will take place because they need to be in solution form. Let us see one activity, that is activity number 2. Take some solid sodium chloride and solid lead nitrate and mix them. They are now in contact with each other. Keep the mixture undisturbed for some time. Are you able to see any change? No, because remember the second condition, the required condition is solution form. Now redo the reaction. Take the aqueous solution of sodium chloride. Please pay attention to this mouse cursor. Solid sodium chloride was taken in earlier case. In case number 2, we will take the sodium chloride in solution form and lead nitrate also in solution form in 2 separate test tubes. Add the solution of sodium chloride to lead nitrate solution. Then what do you observe? A white insoluble precipitate solid is formed very quickly, which is new substance, which is known as lead chloride. Now what was the difference, student? The difference was that earlier in case 1 we have taken in solid form, so there was no reaction. In second case we have taken this in solution form, then in solution form there was a reaction. Now again let us see one common example. All students, you know ENO. ENO is taken for indigestion. ENO is a powder. If you just take the powder, it will not do good to your problem. It is mixed with water and hence it produces effervescence or bubbles, then you get the relief. Third required condition is heating. Some reactants need to be heated to undergo a chemical change. Now in this condition, let us try 2 different methods. In first case, please mix iron and sulfur and do nothing. After many minutes or after 1 or 2 hours, you will see that there is no change. In second case, mix iron and sulfur and try to heat it. After heating, you will see that in a few minutes iron sulfide is formed. So we can say that some reaction also required heating. Next condition required for chemical reaction is light. Some reaction takes place in presence of light. For example, you all know photosynthesis. Plant perform photosynthesis and light is required for this. Plant cannot do photosynthesis in dark. During photosynthesis, carbon dioxide and water are used in presence of sunlight and hence plant prepare glucose. Fifth condition for a chemical reaction takes place is a catalyst. Some reaction need catalyst for speed up or slow down the reaction. Just take one example. Heating of potassium chloride produces oxygen. Heating of potassium chloride produces oxygen. If you heat potassium chloride to get oxygen, it will take much more time. It will be longer duration reaction. But if you mix some manganese dioxide, the reaction happens very quickly. Now in this case, manganese dioxide does not go under any chemical change. It remains in the reaction and no change takes place in manganese dioxide, but manganese dioxide acts as a catalyst and it accelerates the rate of reaction. So students, let us see the definition of a catalyst. A catalyst is a substance which changes the rate of chemical reaction without itself undergoing any chemical change. Different chemical substances are used as a catalyst for different chemical reaction. It means that we have used manganese dioxide here, but in all the reactions we cannot use manganese dioxide. Different reactions need different type of catalyst. So students, these were 5 required conditions for chemical reaction. Let us see the properties or characteristics of a chemical reaction. Chemical reactions are characterized by different or certain changes that can be easily seen or observed. Now, how we can say that there is a chemical reaction? Then students, look at these conditions. These are visual conditions. If any of the condition is there, then we can say that there is chemical reaction. First property of chemical reaction is a change in color. In some chemical reaction, change in color takes place when the reactants are reacting with each other. For example, when a few pieces of iron are dropped in a blue solution of copper sulfate, its a blue solution color slowly changes to light green and red substance is also formed. Now students, try to get the thing. Let me repeat this. Iron is not blue. Blue is copper sulfate solution. After the reaction, we will see light green color. Why light green color is there? Because there was a chemical change. So we can say that first property of any chemical change is change of color. Let us see one activity. Take some sugar in a porcelain dish, keep it over tripod stand and start heating. After heating, what we see? Sugar first melts down and then gets charred into black residue, which is a new substance. So students, we have started with sugar, but we are getting a black substance. Now taste the black substance. We know sugar is sweet, but that black substance is not sweet. Some water vapor is also formed in this reaction. So what happens there? This is the chemical reaction. You can see the figure. We started with sugar and heating the sugar. The black substance was formed. What was the black substance? Black substance was charcoal. Now we can see sugar is different substance and charcoal is different substance. So we can say that in chemical reaction, color change takes place. Second property of any chemical reaction is evolution of gas. In some chemical reaction, one of the product might be gas. Now we can check the gas by its bubble or effervescence. For example, If we mix sodium carbonate with dilute hydrochloric acid, carbon dioxide gas is produced. If we mix sodium chloride or sodium carbonate with dilute hydrochloric acid, carbon dioxide gas is produced. Now we can see the bubbles of carbon dioxide or we can feel it. Let us see one activity for this. Take some baking soda in a test tube. Baking soda means eating soda. Now this baking soda is available in our houses, or baking soda is used in making cake. It is also used in making pizza. Add some dilute acetic acid, vinegar to it. Now vinegar is acetic acid and it is also used in chow mein. Now if we are mixing baking soda to vinegar, what is happen? Strong bubbles indicates evolution of a gas. Look at this figure. We have a test tube and we can see it is baking soda, and now this is vinegar acetic acid. After the reaction we can see that evolution of gas is taking place. So we can say the property of chemical reaction, first was color change, second was evolution of gas. Let us see the third property of a chemical reaction. Third property of a chemical reaction is formation of precipitate. In some chemical reaction, when two solutions are mixed, an insoluble solid known as precipitate is formed. So what is the definition of precipitate? Precipitate is an insoluble solid. Now when barium chloride is treated with sodium sulfate, a precipitate of barium sulfate is formed. You can see this is downward arrow. Downward arrow denotes that there is a formation of precipitate. Now let us see one activity. Students, please follow the mouse cursor which is in right hand side of your screen. Take aqueous solution of potassium iodide and lead acetate in two different separate test tubes. Add potassium iodide solution to lead acetate solution and wait for some time. What do you observe? We observe that a yellow precipitate is formed immediately, which is a new substance called lead iodide. You can see the figure. We are mixing potassium iodide with lead acetate, and now you can see this is yellow precipitate. This yellow precipitate is lead iodide. We will see the fourth property of a chemical reaction. Fourth property of a chemical reaction is change of state. Change of state is observed in many chemical reactions. The reactant may be solid or liquid, which changes into gaseous product or vice versa. For example, hydrogen is a gas, oxygen is a gas. Hydrogen is gas, oxygen is gas, but when this gas hydrogen react with this gas oxygen, liquid water is formed. Second reaction also is there. Copper carbonate is green solid. If we are heating green solid copper carbonate, carbon dioxide gas is formed. So we can say that fourth property of a chemical reaction is a change of state. Now let us see the fifth property, that is change of smell. During some chemical reaction, a strong smell is noticed. Like if we are performing the reaction of ammonium chloride with sodium hydroxide, we can see a small amount of ammonia gas is produced, and ammonia gas has a strong pungent smell. Similarly, lead sulfide react with dilute hydrochloric acid, and we can see hydrogen sulfide gas is produced, and the hydrogen sulfide gas has an odor of rotten egg. Sixth property of any chemical reaction is production of heat. Now calcium oxide reacts with water to form calcium hydroxide, and heat is also produced. Students, this calcium oxide is commonly known as lime, or we call it chuna. When dilute hydrochloric acid react with sodium hydroxide. Now in this case heat is also produced. In some chemical reaction, transfer of energy takes place during formation of product from reactant in form of heat and light, and sometimes in form of sound and electric. Because in every chemical reaction or substance has fixed amount of energy. If you are changing the substance, it means you are changing the internal energy. So during every chemical change, strong heating is observed. Now that strong means it can be measurable, or even it is possible that we are not able to measure it. I welcome class 7 students to this chemistry lesson, and we will continue our discussion with language of chemistry. This is session number 2, and we will check chemical equations. A chemical equation is a symbolic representation of a chemical reaction using symbols and formula of the reactant involved and products formed in the reaction. It means that a chemical equation shows the actual chemical change. Let us check one example. Burning of coal in air is a chemical reaction. Why? In this reaction, new substance is formed. Students, check this. This is carbon, means this is coal, this is oxygen, and this is heat. So new thing is produced, that is called carbon dioxide. So we can say that in chemical reaction, new substances are formed. In this reaction, coal, that is carbon, and oxygen are reactant, and carbon dioxide is the product. In fact, chemical reaction or chemical equation is a shorthand description of chemical reaction. It saves time, energy, and space. Following steps are required to write a chemical equation. First, write the symbol or formula of the reactant on the left hand side with a plus sign between them if there are more than one reactant involved. Second step, write the symbols or formula of the product on the right hand side with a plus sign if there are more than one product. Third, put the sign of an arrow between the reactant side and the product side. Number 4, represent the reactant and the product in their molecular form. Atomic forms are neither stable and nor capable of independent existence. Now let us consider the following reaction. Reaction number 1, zinc oxide when reacts with carbon. Now zinc oxide, this is carbon, products are zinc and carbon monoxide. This is word equation. How we will write skeletal equation? Zinc oxide is ZnO, carbon is C, zinc is Zn, and carbon monoxide is CO. Now this skeletal equation is complete. Second reaction, reaction between hydrogen and chlorine to form hydrogen chloride. Students, you can see this is hydrogen molecule, this is chlorine molecule. Hydrogen chloride is HCl, so this is symbolic equation. Now check this. There are two hydrogen, but we have only one hydrogen. There is two chlorine, but we have only one chlorine. So we can say that this is symbolic equation. This is not balanced. In this reaction, how we will balance, we will see it in a little while. Such an equation is unbalanced one, which is called a skeletal equation. Some more example of skeletal equation are given here. You can see two oxygen, but here we have only one oxygen. You can see two oxygen, we have one oxygen. Here you can see two hydrogen, but we have three hydrogen. So in order to write an chemical equation, we have to write a skeletal equation, and after writing word equation or skeletal equation, we have to balance it. Students, remember, word equation do not require balancing, but in actual world the equations are always balanced. Why to balance the equation? A chemical equation needs to be balanced so as to make the number of atoms of reactant equal to the number of atoms in the product side, because chemical reaction is just rearrangement of atom, and according to law of conservation of matter or according to the law of conservation of mass, atoms are neither created nor be destroyed. So in order to make a chemical equation balance, the atoms in product should be equal to the atoms in reactant. So H2 plus Cl2, check here, we have only HCl, but in order to balance it, we will try to write 2. Now 2 hydrogen, we have 2 hydrogen, 2 chlorine and 2 chlorine. So we can define a chemical balance equation also. A balanced chemical equation is one in which number of atoms of each element on the reactant side is equal to the number of atoms of that element in the product side. So balance equation is always required. So next point, what are the properties or significance of a balanced chemical equation? How it is good for us? What information it gives? Point number 1, it shows which substances or reactant are taking part in chemical reaction and what is the result product. Number 2, it shows both the number of molecules and number of atoms involved in the chemical reaction. Number 3, it makes the study of chemistry universally accepted. So if we take one example where magnesium is reacting with oxygen and product is magnesium oxide. In this reaction, magnesium reacts with oxygen to form magnesium oxide, and 2 monoatomic molecule of magnesium combine with 1 diatomic molecule of oxygen to produce 2 molecule of magnesium oxide. So students, there is a question, how to balance a chemical equation? A chemical equation is balanced by following step. First, burning of magnesium in presence of oxygen. Now magnesium burns in oxygen to give magnesium oxide. So we will write this word equation. Magnesium plus oxygen gives magnesium oxide. We will write their formula. Magnesium means Mg. This oxygen means O2. So this is a skeletal equation. Now how to balance this? Count the number of magnesium here. This is 1, this is 1, this is okay. Oxygen is 2, but oxygen is 1. So we will write 2 here. Now if we are writing 2 here, then magnesium will be 2. So in order to balance magnesium, we will write 2 here also. So what will be the net result of this balancing? We can see this. You can see 2 is written here and 2 is written here. Let us count it. Now we have 2 magnesium, we have 2 magnesium, we have 2 oxygen, we have 2 oxygen. So we can say that reaction is balanced. Students, please note that whenever you are writing a number to balance the equation, you are neither to suppose to insert a number in between the formula. It means do not write anything between MgO. You can write the number only on left hand side of the formula. So let us check this. This is wrong. Do not write 2 in the between, or this is also wrong. Do not write in the right hand side. Let us see one another example. Hydrogen is reacting with oxygen. Now what will be the word oxygen? Hydrogen and oxygen will form water. This is word equation. Now count the number. Hydrogen is 2. Hydrogen is 2. This is okay. oxygen is 2 but oxygen is 1. So we will write 2 here. Now if we are writing 2 here, oxygen is balanced but hydrogen becomes 4. So we will write 2 here. So 2 here and 2 here. Let us check the result. We can see that our result is good. You can see here 2 here, 2 here. Counting is complete. Let us see one another example. Reaction of iron sulfide with sulfuric acid. Word equation will be iron sulfide plus sulfuric acid gives iron sulfate and hydrogen sulfide. We can write the skeletal equation as follows. Now let us count the number. Fe1, this is good. Sulfur 1 and 1, 2. We can check sulfur 1 and 1, 2. Now hydrogen 2, hydrogen is also 2. Oxygen is 4, oxygen is 4. So we can see that counting is very easy. So we can see that as the number of atoms of each element in the left hand side and the right hand side are equal. So equation is already balanced. Now physical state of reactant and product of chemical reactions are shown in bracket. So if in the bracket G is written, this is means gas, L means liquid, S for solid, AQ means aqueous solution, means water solution. Let us check one example here. This is ammonium chloride reacting with caustic soda. You can see S for solid, AQ for aqueous. This is aqueous, this is liquid and this is liquid. So this is a very easy point. And students, as you can see, we have reached the end of the chapter and I have solved every question for you. Everything is marked. I am also supplying you the PDF. Answer will be supplied. Till then, revise the video. We will again come back with next session, next video. Till then, bye bye.